Welcome to Study Loop.
This is the answer to Chapter 13, problem number 5 from the Smith Organic Chemistry textbook. And in this problem, we're asked to consider 2-butanol. And so we're asked to determine what fragments are going to be formed by alpha cleavage of 2-butanol and what fragments would be formed by dehydration of 2-butanol. Okay, and so I've drawn 2-butanol here. And so we should draw it in these brackets or parentheses with the fact that it's a neutral radical here. Okay, and so so for A, we're asked to draw what the products of alpha cleavage would be. And so remember, alpha cleavage means that either this bond that I've arrowed in green can be cleaved, or this bond that I've arrowed in red can be cleaved. Okay, and so there are going to be really two sets of products here. So if the green bond were to be cleaved, we would get this set of molecules. So when that bond is cleaved, we end up with this. So we end up with this carbon with the alcohol still on it, the methyl group here, the hydrogen here, and then this carbon has a positive charge on it. Okay, and so our other product is going to be the part bearing the radical, and so that's going to be CH2CH3, and the carbon here will be bearing a radical on it. Okay, and so if we were to cleave the other bond via alpha cleavage, so the red arrow, so that's going to give us a set of products that look like this. So we will again have so actually I'm going to draw it this way just because it's easier. So there's our CH3. That's going to have the radical on it. So this carbon will be bearing the radical now. And then we will also have the other part of our molecule with the positive charge on it. So that's going to look like this. So there's our alcohol and a hydrogen and our CH2CH3. And so this carbon will again have a plus charge on it. Okay, and then I guess in the interest of completeness, we can list the M to Z's here. So this top piece is going to have an M to Z of 45. And of course, that corresponds to the fragment with the positive charge on it. And then this bottom piece is going to have an M to Z of 59. Okay, and again, that corresponds to the part with the carbon with the positive charge. Okay, and so for part B of this problem, for the dehydration, so we can actually do something very similar. So we need to consider whether the alcohol is going to be lost in the dehydration, and we also have to lose a hydrogen from a carbon adjacent to our carbon with the alcohol on it. So we're talking about either one of the hydrogens that I've arrowed green or one of the hydrogens that I've arrowed red. So again, we're going to have two possible sets of products here depending on which one we lose. So if we lose a hydrogen that I've arrowed in green, our product is going to look like this. With a double bond here. And of course, water. And so I guess, again, it would be proper to draw this bracketed and with the neutral radical. And then if we were to lose a hydrogen from the other side, which I arrowed in red, our product is going to be very similar, just that the double bond will be to that side. So there's our double bond. Here's our carbon. Oops, I omitted a hydrogen. Okay, so there we go. And again, water. Okay, and so so this problem is primarily just showing the difference between alpha cleavage and dehydration, but also pointing out that they're similar in that they each involve something happening to the side of the carbon with the alcohol on it. So for alpha cleavage, it's going to be cleaving either of those two carbon-carbon bonds. And for dehydration, it's going to be taking a hydrogen from either of the carbons attached to our carbon with the alcohol on it. And so that's the answer to chapter 13, problem